recording my screen. Rows are red. Rows are the horizontal. Columns are vertical. The row number comes first. Column number comes second. Capital letters to name a matrix. Lowercase letters for the entries. When we talk about two matrices being equal, we can in fact have two matrices being equal. I need to change this to the normal. If I had A is, I don't know what's doing. 1, 2, 3, 4. If I had B as 1, 2, 3. I have no idea why that's doing that. And let's say I had C as 1, 2, 3, 4. Two things have to be true about matrices. I'm actually going to make a fourth one. 1, 2, 3, 0. So two things have to be true about matrices for them to be equal. First, they have to have the same order. So in this case, the only things that could potentially be equal are A, B, and D, since they have order of 2 by 2, whereas C has order of 1 by 4. So C cannot possibly be equal. And then the second thing that has to be true is every entry has to be the same. So A11 has to equal B11, A12 has to be equal to B12. So every, essentially, IJ has to be equal to every BIJ. So in this case, A and B are equal because we have 1, 2, 3, 4, 1, 2, 3, 4, but neither is equal to D because it has 1, 2, 3, 0. So equality, fairly straightforward. If the two matrices are exactly the same, meaning same order and same entries, then they are equal. So I'm going to type that super quick. So two matrices are equal if and only if A and B have the same order and every entry pair, Now, again, order becomes very important when we get to our next operations of addition and subtraction. So I'm going to give some quick examples and ask you if you think we can even add them or not. -4, 0, 1, 2. B is 2, 3, -4, 0, and then C is equal to 2, 9, 5, -1. I'm going to put a comma between those so we know that they're separate. You normally don't put commas, but I kind of got scrunched. B plus A. And number 3 is C plus B. number 4 is A minus C. Without having to do any work, does anyone take a guess as to which of these 4 are actually possible to do? So I'm going to repeat that because I forgot to keep recording. So 1 and 2 are correct, as Min was saying. A is a 2 by 2 and B is a 2 by 2. So they have the same order. 3 and 4 don't work because A and B are 2 by 2s, but C is a 1 by 4. So different orders cannot be added or subtracted. So we need the same order. I need to go back to using the text tool. So if we don't have the same order, we can't add or subtract. If we do have the same order, all we do is look at the actual entries themselves. So if I started with, let's just do number 2 first. So I'm going to have number 1, and I'm going to have number 2. All I'm doing is adding the entries. So I'm going to look at what would be 1, 1. Well, it's negative 4 plus 2. So it's just going to be negative 2. Then I'm going to look at 1, 2. It's 0 plus 3. So this is just 3. For 2, 1, it's 1 plus negative 4. So this is negative 3. And then for 2, 2, it's 2 plus 0. So this is just 2. So there's nothing different about adding the matrices as long as they have the same order. If you don't have the same order, you can literally just say does not exist, DNE. For here, for number 1, it's going to be A minus B. So this would be negative 4 minus 2. So this would be a negative 6. This would be 0 minus 3. So this is a negative 3. We would have a 1 minus a negative 4, which is actually going to be plus. So this is 1 minus a negative is addition. So this is a 5. And this last one is going to be 2 minus 0, which is just 2. So as long as you have the same order, I'm just going to use the text. The text tool is so much easier. So if you have the same order, and it disappeared on me. We can just add or subtract each entry. So matrix operations are not different in how you would perform them for addition or subtraction. So this would be A sub I sub j plus b sub I sub j for addition, and then for subtraction you just do a sub I sub j minus b sub I sub j. We also have one other nice operation that translates from regular algebra to matrix algebra, which is scalar multiplication. So scalar multiplication is when I just have a constant c. I'm going to actually write this out. Multiplication. So if I had C times some matrix A, all I would do is multiply. I need to actually write that C as a constant. So C is constant. We just multiply each entry by C. Did half of the screen just turn white for you guys or no?
I don't think so.
It's like you can still see what my mouse is pointing to.